Hello, folks from Bida. Good morning. Um, I'm really excited to be here this morning. First off, I would like to apologize for not being there in person. I actually planned to do so, but as God we have it, joining every one of you virtually. I'm really excited to be here. Um, I would like to thank the organizers for bringing us together. Um, Organizing Devfest, a kind of big event like this is not easy. We that have normally work with people that plan small events, small conferences. We really know what it takes to organize this kind of events. So shout out to the Devfest Bida organizers. We really appreciate you, and we want to use this medium to thank you for the opportunity given to us to speak with the community members and to collaborate with everyone and network today. So I'm really excited to be here, and I can imagine what we are going to be learning from each other this morning. So I am Mudasiru Rasheed, and I'm a Google Cloud innovator. What we do in Google Cloud, what we do as a Google Cloud innovator basically is to advocate, talk about Google Cloud products, services given to us by through Google Cloud, and um, opportunity coming into Google Cloud, and how we can leverage as a business, as a personal user, as a student, and wherever you are doing, how you can leverage on Google Cloud and to innovate and come up with ideas and different things. Um, I also do DevOps. So some people may be, is there anything like DevOps? You're not supposed to be a site reliability engineer. I'm not available for that debate today, so don't call my number. I won't pick it. So I'm a DevOps engineer and also a GitHub campus expert. If you don't know, seeing that you'll be like, "Are you a student?" Yeah, I'm a student. Currently studying computer science at Federal University of Technology, Mina, and most time I write JavaScript and sometimes write Python. And right now on my current role, I write C++. So uh, I do write programs several times rather. So most of what people know me to be is a community developer. So most involved in community, most especially student community, helping students to learn various technology, helping them to choose their career, and giving out resources to them to learn several things. And if I'm out of those stuff I've mentioned, I'll be focusing really on engineering, writing programs and all, and collaborating with other team members to build solutions and participate in hackathons and challenges around the world. So let's get started. Our point of discussion this morning is basically monitoring and observability, a tool in GCP for DevOps. So there are kind of a lot of jargons in the topic. You'll be like, what do you mean by observability? What are we observing? What's DevOps? You know, on the on-premise servers, when an organization is giving out or rendering a kind of service for their customers, there's this the availability is not 100%. Like, okay, they cannot say, oh, this service that we're giving out to you, it's 100%, like 100% availability. And because of that, when failures comes up, they need to set out certain steps or certain measures to be able to see that, okay, at this point our service is done, at this point our service is consuming memory as more than what we expect and every other thing. So that's on-premise servers, like on-premise system. But then if it is not on-premise, everything has been pushed to cloud. So be it their database is on cloud, their front-end application is on cloud, their mobile app, everything they have is being deployed to a cloud service, be it public or multi-cloud or private cloud. So that's what they have. But then with they still don't have 100% availability. For that reason, they need to set out a kind of observability tools or monitoring tools to be able to know when there is issue at any point in time. So that's the summary of what we want to discuss, and I believe you are going to learn a lot as we proceed. So what's DevOps? Okay, so in the past, what organizations do basically is they will have development teams working. Development teams will comprise of the programmers, those teams that write programs, that build the applications, that build the system, probably being run on by the company, the internal applications, the applications or the system they are giving out to their customers as a service. And those teams that are in charge of that are the development teams. So they are mostly programmers. And we have other teams which are called operations team, and their work is basically to ensure the reliability of this system being built by the development teams. Seeing that, we know that there is a kind of correlation or there is a bit of connection between them, because it is the system being built by the development team that is going to be managed and ensure the reliability, and the reliability of it should be ensured by the operations team. So it is the code written by development team that will be transferred to the operations team. But then in the past, both the development teams work on their own. Development teams work in a silo, and the operations team also work in a silo. So we need a concept or a principle or a philosophy that we bring these two teams together just to ensure collaboration. So that's what DevOps is. So DevOps is a series of principles and practices to help increase collaboration and efficiency between development team and the operations team. So some people say, okay, you can't just call it a series of principles. It is a philosophy on its own, and what it does is basically to ensure there is there is an increase in the collaboration between the operations team and the development team. So what DevOps comes to do is just to remove the barrier between the development teams, which comprises of the programmers and every other team that comes under them, and the operations team, which comprises of the testers and every other teams comes under them, the security engineers. So under that, so we need the DevOps comes to bring out or to eradicate the barrier between them and ensure accurate and efficient collaboration between the both teams. So for that, the team at Google comes up with objectives for this DevOps that we're talking about. So the number one objective is reduce silos. They mentioned that what DevOps comes to do for us is just to reduce silo. What does this mean? It means that it helps us remove the barrier between different departments, different silos we have in the organization. Okay, in an organization where the operations team work on their own and the development team work on their own, with the concept of DevOps, if they accept or adopt DevOps as a culture in their company or in their organization, what they will be able to achieve, number one, out of those things is to help them reduce silos, it ensure collaboration between different teams in the company. And again, it's encourage a company or an organization to accept failure as normal. We know all these things that we are using, they are not 100% reliable. I've mentioned that earlier. And computers are meant to fail at a point or not responding at a time, or even the internet that we are using as I'm talking to us virtually, there may be a network went off, or like everything goes off and we'll not be able to see each other, we'll not be able to hear each other. So at that point, we should know that as a person that is building for the whole human race to use or the whole world to use, we should know that at a point or at a particular level in life, there will be a failure in our system. But then for us to be able to rectify those failures and to minimize that failure is where we need to adopt DevOps culture and everything DevOps brings to us. The third thing is basically implement gradual change, incremental changes being added to our solution or to our system for our customer to use will be very easy for us to check, to debug, to test, to even roll back if we deploy it to production and it started misbehaving, it started breaking, or started doing what we are not expecting it to do. So if it is incremental, it is very small, it is being released um, as in a small chunk, not bundle everything together as a system and deploy it to production. So imagine you are building a system and you have to build the complete system, bundle it together, throw it to production, and at production the system does not work the way you want. It means you have to roll back the whole system back to the development teams, and the development teams will now be the one to um start reworking it, fix the errors and every other thing. But then if it is incremental, it is just the feature that is not accurate, or that is not working very well, that you have to roll back and be able to carry on, and your customer will keep enjoying your product. The one you have up and running, then the one that you remove will not be accessible to them. Leveraging on tooling and automation, that's fourth objective of DevOps. So everything that you do manually, DevOps comes to tell you that you need to automate them. Look at them, check how you can automate them and make them more fast and more reliable. And the last objective is measure everything. What you cannot measure, we'll talk about that in a bit. Basically, what you cannot measure, you will not be able to correct them at any point in time. And if you cannot measure, you can't say whether it is successful or it's a failure, whether your company is making progress or your company is at a particular point, whether you're not making progress or you're making progress, if you cannot measure it. So it means you have to measure. The measurement is key. You have to measure everything. I'm going to talk about measurement, or the concept of measuring everything, a bit as we progress in the discussion. Imagine you log on to a website, and what you can see is this bunch of errors. You'll be like, 503, service not available, the service downtime, and every kind of error that you can think of. At that particular point, you'll be looking for that contact us button that you have been seeing from ages, that you never click on. Like, I need to tell this team that this thing is not working. And imagine this error that you are seeing as a customer. The development teams are not seeing it. The operations team are not seeing it. Imagine that. So that's one of the critical points where this discussion come into play. If that is the case, we need to set up a kind of system that will alert the development team that, oh, your system is done. Oh, your system is consuming memory as more than as expected, and is consuming low memory as expected. So the development team will be able to come into play. The team will be able to come and see, oh, we need to fix this what we need to remove, and every other thing that needs to come into place. So that's the number one reason why this discussion is very important. Secondly, this according to a research from the Flexera team, they report that if there's no monitoring to set up and observability to set up correctly by an organization, there will be an ineffective control cloud usage. It means the spending, or the how company being charged of what they use on the service or on cloud will be very, very difficult, and will be very they will have a kind of ineffective control over it. And what does that mean is that, okay, wasted spending, according to their research, was around 35%, and the self-estimated wasted spending with the company that owns that cloud service, that are running the application on that cloud service, is their own estimated say wasted spending is basically around 25 or 28%, or 27%. And the additional wasted spending is around 8%. But then what they were able to calculate was 27, and in the real sense it was 35, and another additional one was 8%. So seeing all this, bringing all this together will be a kind of ineffective control cloud usage. I think being they set out tools to be able to monitor all this stuff, they don't have to pass through this rigorous spending. They don't have to waste money as much as they do here. So I want to share three things with us that we should take note of. If you have not been listening to what I've been saying since morning, at this point, you should take out your pen and write it down. You cannot measure what you cannot correct what you cannot measure. Yeah, you cannot even measure what you cannot correct. Yeah, I don't know, maybe that sound well, but then the point is you cannot correct what you cannot measure. So For you to be able to correct anything in your application, you need to be able to know that whether the service is up or the service is down. So you need to measure it. You need to be able to have a kind of system or a way of measuring it. If you cannot measure it, you cannot correct it. If you cannot measure it, you cannot correct it, and you cannot correct what you cannot measure. So the second key point that I want us to go with is direct observation of failure leads to quicker rectification. So if you are not aware of a problem, there's no way you can provide solution. That's the summary. If you cannot um if you are not aware of a particular problem, you can never provide a solution, whether you are whatever you are, whether you're a genius or whatever you call yourself. If you are not aware of the problem, you cannot provide a solution. Same way in our discussion here, if you cannot have if you can't observe the problem, don't mind me, if you cannot observe the problem, you can never provide or rectify the solution or bring out the solution in the long run. So direct observation of failure leads to quicker rectification. And lastly, from the Dora team are the DevOps research team, which claims that okay, they carry out more than research or from over 33,000 organizations just to ensure and hear from them how DevOps philosophy or DevOps principle helps the organization to grow and thrive in the whole space. So they said good monitoring is a staple of high performance team. So if you want your team if you want your team to be high performance team, definitely you have to have a kind of a good monitoring, probably on your system, on good monitoring on your system, on your team. So their conclusion was good monitoring is a staple of high performing tools, of high performing teams. So GCP monitoring and observability tools. There is what we call Google Cloud Operations Suite. Google Cloud Operations Suite, what it means is it's a group of packages, a group of tools being packed together, and just to help you to monitor, observe, debug, troubleshoot, and every other thing that you need to do on your system as applies to you when you are running an on-premise system. So at this point, the Google Cloud team categorize them into two categories: the operation focus tools and application performance management tools. So these two categories are the one that we're going to be looking at, and we'll see what fall under them. And so for the operation focus tools, we have the cloud monitoring. The cloud monitoring is the one that you can use to set alarms, get metrics, create dashboard, and every other thing that comes under it. The cloud logging is also a tool that will help you to generate logs, events from your system, from different platforms. The events will be emitted into a log file, and you can check out the log file to fix any error that comes with it. So we have the error reporting and the service monitoring. The application performance management tools are the cloud debuggers, the cloud trace, and the cloud profiler. What's the difference between this one? The application performance management tools is basically for you to troubleshoot even while your application is up and running, and you don't have to stop at the point when you are using the cloud debugger to debug your system. And the cloud trace is just for you to measure or to detect error in a microservice or a containerized system where where the component of your system is being divided into different chunks. And when there is error at a point, you may not be able to fix it where the error is coming from, but using the cloud trace, you can easily check where the error is coming from, fix it, and optimize your code in the long run. So what does a cloud monitoring does? So a cloud monitoring is basically to check the edge check, to make an edge check, and to provide a visibility to performance uptime. And apart from doing all these things, it also helps to configure alarms for you to generate alerts when there is an issue, when there is a low memory or high memory consumption, or there is any issue, or the system is down, when there is downtime, when there is system disruption, everything that can happen to your system. You can configure cloud monitoring, configure use it to configure alarms where you will be able to generate alerts and get, probably you want a WhatsApp message, you want a text message, you want an email message, just to get a notification that, oh, your system is done. You have to come up and rectify and bring out the solution. And as against that, under the operation focus tool, we also have the cloud login. The cloud login is basically where to just generate log file, and a log file will consist of events from different services that you are running, be it you are running GKE, which is Google Kubernetes Engine, or you are running any kind of virtual machine or any Google Cloud service. So the event generated, it will help you to check, get the root of the problem, or be able to see that, okay, where the error is coming from, and you'll be able to trace the error. And tracing the error very easily will give you a kind of sense of how you can fix it, and you can fix it with very easy. Another one is the application performance tool management, like management tool basically. Application performance management tool, one of them is Cloud Debugger, and the Cloud Debugger is a tool that will help you to debug your system while in production, and you don't need to even stop your application before you can do that. You can search through the source code without stopping your application, without affecting your customer. Your customer will still be using the application. So it's an application performance monitoring tools, and you inspect the code, and your customer did not see it. You'll be able to check whether how your system being how your system works in production, how the code being modeled together, and how everything works together in production. And you don't have to stop it. Your system will keep on running. And the last one that we are going to be talking about today, because of our time, I can see some people are be like, let these guys finish what they're saying. Let's go on to another thing. Yeah, I'll stop talking right now. So basically, another tool that we are going to be talking about, the last one today, is the Cloud Trace. And the Cloud Trace, what it does basically is a tool that helps us to be able to trace an error in our system, most especially when our system is being divided into different chunks. When you are building a microservice, when you are building a container, you are using containers to deploy your system and all of that. So basically, you'll be able to trace. At that point, you will not be able to know where the error is coming from due to the different components that your system comprises of. So Cloud Trace will help you to trace the error, fix the error, and optimize your code in the long run. So you get to uh, do any other thing that you need to do. So measure everything. I mentioned this, that I will have to come back to measurement. So you have to measure everything. You need to keep track of the health of your system, how healthy it is, how unhealthy it is, the memory consumption, the how available it is, and every other thing that comes under it. As a DevOps engineer, it is your role, because you are combining the role of an operations team as a development with your role of developer. And that's why some people say, oh, we are not a DevOps engineer. The debate was not available in the beginning. So some people say we are not a developer, we are site reliability engineers. And what we do is basically to ensure, because we are combining two roles together, the role of software engineer with the role of operation teams, and so we ensure reliability of your system. So you need to, as a whatever you call yourself, be it DevOps, be it a DevOps engineer, be it a site reliability engineer, so you have to ensure measurements. You have to measure everything, keep track of toil automation, you have to keep track of reliability, you have to keep track of the health of your system. So don't forget to keep track of everything. So if I talk about me, I have to stop here. Is that I never post WhatsApp sticker, and I've never watched an anime. So if you have a recommendation for me, I'll be glad to see that. And you can tweet me on Twitter. send me a DM on Twitter, tag me when you make a tweet, probably about the discussion, or you have anything to ask, or you have anything to say. You can see me at IBN_MUDATHIR. So it's nice speaking to every one of us. Thank you so much for listening. And thanks to the team for bringing us together, the Devfest team, Devfest Bida team, for giving us the opportunity to talk to each other. So if you want to learn more, you can check out these two links. There's in-depth story about this discussion there. So thank you so much. Thank you. Bye for now. Bye.